Hello there, this is Ms. Nakayama. Today's lesson is 2.5, Zeros of Polynomial Functions. So what we're going to cover in this lesson, first off, is using the rational zero theorem to find possible rational zeros. Next, we're going to find zeros of a polynomial, solve polynomial equations, and then use the linear factorization theorem to find polynomials with given zeros. So to start off with, the rational zero theorem. If you had this before, you might have heard it as the rational root theorem. Same kind of thing. But if you have a polynomial with integer coefficients, and if it has a rational zero, what do we mean by rational zero? We mean a fraction, p over q, where p over q is reduced to lowest terms. Okay? If it has a rational zero, then we know that p is a factor of the constant term and q is a factor of the leading coefficient. So I find it easier to remember a visual. Okay, we know that this is p, that's q and this is p. So I think of it like that, drawing an arrow. P is going to go over q, so I'm going to find the factors of p before I find the factors of q and list all the possibilities. So this is an example of what you'll have to do. List all the possible rational zeros of 4x to the fifth plus 12x to the fourth minus x minus 3. So again, I'm thinking to myself, I got to put the factors of 3 over the factors of 4. So I'm going to come over, and there is always a plus or minus, y'all, involved. You always have to think about the positive or negative of these possibilities. So first off, the factors of 3 are 1 and 3, and the factors of 4 are 1, 2, and 4. So now I'm going to list all of the possible combinations, okay? And first off, you can think of, you got plus or minus, because I said you can write plus or minus before each one, or you can write it at the beginning. But you're taking the numerator, each number in the top, and putting it over each number in the bottom. So 1 over 1 is 1, 3 over 1, then I'm putting 1 over 2, and 3 over 2, and then I'm putting 1 over 4 and 3 over 4. And if you put it in some kind of order, then it helps you know when you've listed all of the possibilities. Okay, that was a close one, just sneezed. Anyway, finding the zeros of a polynomial function. So I have x cubed plus x squared minus 5x minus 2. So these steps that you want to use to find a zero. First off, you want to list all the possible rational zeros. And that is the factors of 2 over the factors of 1. Well, in that case, it's just plus or minus 1 and 2. Next, I'm going to go use the table feature on my calculator. And if you don't have a table feature, y'all, you just got to do it by hand. But I would encourage you to look at all of those numbers or figure out those numbers between -2 and 2. So I put those in the table, and I'm looking at the table. And to find a zero means I want to know where there's a zero on the right side. So as you can see down here, that is a 0. And so that's where I'm going to start my synthetic division, which is the next step. So to set up my synthetic division table, if you remember, looks like that. I'm listing the coefficients of my polynomial. 1, we just talked about this on the last video. Okay. And I'm going to use that first 0 I found. So that means that's going to be a 2. And I know that I have to get a 0 at the end. Okay, y'all, again, it just helps you not make mistakes and keep things on track. Okay, so remember, to do synthetic division, we bring down that first number, 1, and then I multiply and add, multiply and add, multiply and add. So remember also that we start, what is the first polynomial that I have is a third degree, which means this next one is going to be a second degree. And so those are the coefficients of a quadratic equation. And when you look at that, as I've talked about before, it's easiest to factor, but there are no factors of 1 that add or subtract, add in this case, to give me 3. So that means I'm going to have to use the quadratic formula. So that's -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And when I simplify it, I get negative 3 plus or minus the square root of 5 all over 2. You will have to give that exact answer like that. And so my zeros are 2, that first one we found in our table, but you have to do the synthetic division to find the other ones. And the other ones, of course, are negative 3 plus or minus the square root of 5 all over 2. Okay, some things to keep in mind when you are doing this. Properties of roots of polynomial equations. Okay, first off, whatever the degree is, that's how many roots you're going to have. So in this last problem, I had a third degree polynomial. I can account for 3 roots. That's 1, and negative 3 plus or minus is 2 more. So that's a total of 3 roots. Okay, the other one is to remember that if you have a plus bi, then you're also going to have a minus bi, because those are complex numbers, and imaginary roots. They always come in pairs because they're coming out of that quadratic formula. So look at this problem. This one's a little more challenging because it's a 4th degree. So you might think to yourself, I'm going to have 4 roots. I need to account for 4 roots. Okay, so the first thing I'm going to do is to list my possible rational zeros, and that would be plus or minus the factors of 13, which are 1 and 13, over 1, because my leading coefficient is 1. All right, then I'm going to go look at a table, and I am going to go plug in. Again, I'm looking, I only have to look at the numbers that I have. Okay, so I looked at negative 1 and negative 13, positive 1 and positive 13. So I found out that 1 right here gives me 0. So that tells me that's a 0 of my polynomial. So now I'm going to go to my synthetic division. I'm going to list my coefficients: 1, negative 6, 22, negative 30, and 13. And I'm going to divide by 1, and I'm going to know that I'm going to get a 0 when I finish dividing. So I carry down my 1, then I multiply and add, multiply, add, multiply, add, multiply, and add. And so I got 0. So I know I've done that correctly. Now, this is a 4th degree, which means this one is a 3rd degree. And if you put those numbers, 1, negative 5, 17, and negative 13, as a cubic, I still can't factor that. So I'm going to try again. Okay, but keep in mind, this is really important, y'all, when you do this. But this polynomial right here, the coefficients, that is the coefficients of what we call a depressed or reduced polynomial. So I'm going to try 1 again, because I've got the same numbers, and they tell me that my table clearly says the only one that's a 0 is a 1. So I'm going to try 1 again, and this time, when I divide it, what we got? Bring down my 1, multiply, add, multiply, add. Oh, I don't know what I'm getting, so I didn't put a 0. But when I multiply and add, I get 0. So now I have a 2nd degree equation. So I've got x squared minus 4x plus 13. Again, there are no factors of 13 that add to give me 4. So I'm going to have to use my quadratic formula again. We just went over that. And when you write that all out, what I'm looking most for and what you need to pay attention to is what's under the radical. That's called our radicand. So it simplifies to negative 36. And the square root of negative 36 is 6i. So this becomes 2 plus or minus 3i. So my zeros are 1, we found in there. I don't need to list it twice, okay? But it is a 0 twice, and then I have 2 plus or minus 3i. So when we talked about having 4, okay, the 1 counts twice because I have a 1 here and a 1 here, and then I have 2 plus or minus 3i. Okay, and that goes along with our fundamental theorem of algebra, which says if I have a polynomial of degree n, it has at least one complex root, because any real number can be written as a complex number. Okay, now our linear factorization theorem says anytime that you have factors, whatever factors, I can write it as a polynomial as a product of those factors. any nth degree polynomial can be expressed as a product of non-zero constant linear factors. That's what I just said. Okay, so if you think about what we just did, we had the zeros of 1 twice and then 2 plus or minus 3i. Well, that means that I could say that that is a polynomial of x minus 1, and then x minus 2 plus 3i, or x minus 2 minus 3i. The order of those doesn't really matter, okay? But we don't get to leave it like this. We actually have to multiply it out and make it look like this guy right here. And for that reason, I'm doing some examples, because you got to be able to do that, put it in my math lab. Okay, so look at this one. Find a third degree polynomial with a function f of x with real coefficients that has 4 and 5i as zeros, such that f of 2 equals 16. Well, if it has 4 and 5i, we know it also has negative 5i. If it has 4, you're going to start this problem out by saying, okay, x equals 4, and then x equals 5i. Oh, poo, I didn't want to do that. Hold on. Let's go there. Nope, either way. Okay. X equals 5i and x equals negative 5i. Then I need to square both sides of the equation. And but before I go there, this one, you want to take each equation and set it equal to 0. So this is going to be x minus 4 equals 0. When I square both sides of this guy, I'm going to get x squared equals 25i squared. And because you only have to pick one of these to square, I'm going to pick the one that doesn't have a negative in it. So I'm going to stick with the one that we had to begin with. X squared equals 25i squared. And then I'm going to bring it to one side. Well, actually, before I do that, I'm going to say that 25i squared is negative 25. Then I'm going to bring it to one side. And then those are my factors. So that tells me that f of x equals x minus 4 times x squared plus 25. So whatever I had equal to 0, I made it a factor. Now, I have to remember that leading coefficient, so you need to think about the fact that there's another number there. A, I don't know what A is. I got to find it, but that's what this right here is telling you. It's telling you that if I plug in 2 for x, then I'm going to get 116 for y. So I'm going to plug this in. 116 equals, and I'm plugging in 2 for x. So there's going to be a 2 here and 2 squared here. And when I simplify that, I have negative 2 and 29. Multiply those out, get negative 58. So I find out that a is equal to negative 2. So now I'm going to go back up, and I'm going to put this into that equation. So I have negative 2 times x minus 4 times x squared plus 25. I still have to multiply that out, but these are two binomials. So I'm going to foil it because it's two binomials. So I got the first terms give me x cubed. The outside terms give me plus 25x. Inside, negative 4x squared. And the last gives me minus 100. Okay? Then I'm going to distribute my negative 2. And then I'm just going to put it in standard form by putting it in order. So that's all you got. Okay? One last problem. All right? And then we'll be done. Find a third degree polynomial f of x with real coefficients that has negative 3 and 2 plus 4i as zeros, such that f of 1 equals 68. So I have, if I have 0, a 0 is negative 3, then I know that x equals negative 3. And I know that x equals 2 plus 4i. So on this one, y'all, I'm still going to take my x equals negative 3, set it equal to 0. So I'm going to add 3 to both sides. But when you have x equals 2 plus 4i, you need to get the I by itself. So in that last one, I didn't have a plus in the problem. I just had the number over there. But if I have 2 plus, a plus bi, I need to isolate the I part. So this time, I'm going to bring it down to x minus 2 equals 4i. Then I'm going to square both sides. And then if you remember our PST, this is going to become 3 terms. X squared minus 4x plus 4 equals 16i squared, which is the same as negative 16 because I squared equals negative 1. So I'm going to add 16 to both sides and get x squared minus 4x plus 20 equals 0. Now, because they told me f of 1 equals 68, then I've got to remember that a value in front when I put my factors together of x plus 3 times x squared minus 4x plus 20. So f of 1 equals 68 means I'm going to put in 68 by itself, and then everywhere I see x on the other side, I'm going to plug a 1. So 1 here, and 1 there. And when I simplify those parentheses, I get 4 and 17. 4 times 17 is 68, so I find out that a is equal to 1, which means the only thing I have to do to finish this problem is to multiply out my trinomial and my binomial. And so I'm going to put the trinomial on top. I've talked to y'all about this, times my binomial. And I've told you about this vertical method of doing it. So 3 times 20, and then 3 times negative 4x, 3 times x squared, and then x times 20, lining up my like terms, x times negative 4x, and then x times x cubed. So when I add those together, I get my final answer, which is x cubed minus x squared plus 8x plus 60. So that is all you need for solving polynomial functions and writing a polynomial in standard form with the linear factors. I hope you wrote down some really important things to help you master these concepts. Thank you so much for watching, and y'all have a great